Welcome to part 2 about acid-base imbalance. Now we're going to discuss my favorite mnemonic to use to help you figure out what acid-base imbalance you're dealing with. So the mnemonic is ROME, like the city, ancient Rome, R-O-M-E. It stands for respiratory, opposite, metabolic, equal. So there are lots of different types of memory devices, little charts you can make. Find what works for you. This is how I learned it and how it makes sense in my brain, but feel free to use whatever tool just is easiest for you to remember. So let's start with respiratory opposite. So remember we talked about acid-base imbalance. You have the respiratory system involved, you have the metabolic system involved. So with the respiratory system, like we mentioned before, where the carbon dioxide goes, the pH will do the inverse of that, or the opposite of that. For example, if you remember, anything that is a pH above 7.45 is considered alkalosis, or more basic than normal, 7.35 to 7.45. So if you have a pH that is going up or greater than 7.45, you're going to have a PaCO2, or just CO2 for short, that goes down. So they move opposite of each other. So as the pH goes up, the CO2 is going to go down. So respiratory opposite. Inversely, with an acidosis, as your pH goes down or becomes more acidic or acidotic, your CO2 level is going to go up. So as your pH trends down in a respiratory imbalance, your CO2 is going to go up. So remember, your acid-base imbalances, we have respiratory or metabolic. In respiratory acidosis, alkalosis. And in respiratory alkalosis, the pH goes up, the CO2 goes down. In a respiratory acidosis, the pH goes down and the CO2 goes up. So respiratory opposite. Now, when we're talking about a metabolic imbalance, so we can have metabolic acidosis or metabolic acidosis, you're going to have these things trending together. Okay, so as the pH goes down, the bicarb level, or the HCO3 level, is also going to go down. Metabolic equal, they trend together. Now, with an alkalosis, in a metabolic imbalance, as the pH goes up, the bicarb is going to go up. So metabolic equal, they trend equally, they go equally together. They're best friends and they travel in whatever direction together. So to review, you've got two different types of acid-base imbalances. You have a metabolic imbalance or a respiratory imbalance. In a respiratory alkalosis, the pH is going to go up and the CO2 is going to go down, and that's how we're going to determine what kind of imbalance we have. In a respiratory acidosis, the pH is going to go down because it's acidotic, and the CO2, or PaCO2, is going to go up. In a metabolic acidosis alkalosis, so a metabolic imbalance, an acidosis, the pH is going to go down because it's getting more acidic, and the bicarb is also going to go down because remember, bicarb base. So my base is going to decrease as my pH decreases. So if I have less base, I have a lower pH because I have less kind of buffering happening. Now with a metabolic alkalosis, it's the opposite, right? So as my pH goes up, as I get more and more basic, I'm going to have more and more HCO3 or bicarb. So they trend together. So a little confusing, but as soon as you kind of wrap your brain around it, and as soon as you do some practice exercises, it gets more and more intuitive and less clunky, and will make more and more sense. So with that, let's practice. So if you have something to write with, this will be really helpful for this part. If not, pause the video, go grab a pen and pencil or tablet or whatever you need to do in your life, and we're going to do a practice. So we have a pH of 7.26. So if you have, we always start with the pH. So a pH of 7.26, is that going to be an acidosis or an alkalosis? So remember, our normal pH is 7.35 to 7.45. So if I have a pH of 7.26, I am less than 7.35. And so I have an acidotic pH. So I don't know if I have respiratory or metabolic yet, but I know that I have an acidosis with the pH of 7.26. Now my next level that is given is a PaCO2, or a CO2 level of 60. Now if you recall, the normal CO2 levels are 35 to 45. They kind of match up with those pH numbers, which is very convenient. So if I have a CO2 level that is 60, that is way far on the end of what I would expect my CO2 level to be within the 35 to 45 range. So I have a CO2 level that is going up. I have a pH level that is going down. So my two measures are moving opposite of each other. So whenever I have things that are moving opposite of each other, I have a respiratory opposite, or we can term it a respiratory acidosis, because that pH, remember, was 7.26. Now you also want to look at the bicarb in this case to determine if you've got some compensation. So is my body trying to correct the problem here? Now if we look at the bicarb in this example, it is 26. So the HCO3 is 26. So remember, normal bicarb is 22 to 26. So in this case, I have a normal bicarb. So there's not any compensation happening here. So pH of 7.26, acidosis. My pH is going down. My CO2 level is 60, which is greater than 45, so it's going up. So I have a respiratory opposite. I have a respiratory acidosis. Easy peasy, right? All right, let's do another example. So we're going to start out with a pH of 7.29. So remember, normal pH, 7.35 to 7.45. So I've got a pH that's going down. Now my PaCO2, or my CO2 level, is 44. So if you remember, normal CO2 levels is 35 to 45. So I'm actually within normal range for my CO2. So I'm not going to be looking at the respiratory problem for this imbalance. So now we're going to go to our bicarb level, or our CO3. That is 20. So if you remember, normal bicarb level is 22 to 26. So I have a pH that's going down, remember 7.29. It's getting more and more acidotic. I have a CO2 level that's normal at 44. And then I have a bicarb level that's also going down. So I have a metabolic equal. So I have a metabolic acidosis. My bicarb is going down, my pH is going down, and I've got an acidotic pH, so metabolic acidosis. All right, now let's move into our alkalosis. So with this one, we've got a pH of 7.51. So in our pH ranges, that's going to be greater than 7.45. So in this case, I have a alkalosis with that high pH, okay? Then we look at the bicarb level. In this case, sorry, not the bicarb, the CO2 level. CO2 level here is 37. So if you remember, CO2 is 35 to 45, so a level of 37 for my CO2 would be normal. So the CO2 level, or the respiratory system, is not my problem here. So now we're going to look at the bicarb. So my HCO3 level is 29. So remember, 22 to 26. So I have a bicarb that's going up. Remember that pH is 7.51, so that's going up. So I have an alkalosis, and it's metabolic equal. They're trending together. So I have a metabolic alkalosis. All right, one more example. So I have a pH of 7.49. So are we acidosis? Are we alkalosis? In this case, we would be alkalosis because we've got a pH that's high. It's 7.49. Now we're going to look at the PaCO2. It is 20. So if I have a PaCO2 of 20, that is less than normal, right? Because it's 35 to 45. So I've got a pH that's up. I've got a CO2 that's down. Now we're going to look at the bicarb to see if we've got any compensation happening. So my bicarb level is 24. So remember, 22 to 26, bicarb's normal. So I've got a pH that's going up. I've got a CO2 that's going down. So in this case, I have a respiratory opposite. So I have a respiratory alkalosis with that pH of 7.49. All right, hopefully those examples helped. and we will break down some more examples in further videos.